In this video, I'm going to show you how to do A-Level Maths, Edexcel, Pure Maths 1 from June 2018, question 14. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuitions both in person and online. For in-person tuitions, I live in Buckinghamshire, England. Okay, let's get started. The curve C has parametric equations. X is equal to 3 plus 2 sine t, and y is equal to 4 plus 2 cos of 2t. Show that all points on the C satisfy this Cartesian equation. Y is equal to 6 minus x minus 3 in brackets, all squared. Okay, looking at the parametric equations, the thing that should jump out at you is that the parameter for cos is 2t, whereas the parameter for sine is t. So this suggests we should use the addition angle or double angle formula to change the parameter cos into t, and then use trigonometric identities to express y in terms of sine t, and that way we'll be able to substitute one equation into the other and eliminate sine t. Okay, so what do we know about cos 2t? Cos of 2t, using the addition angle formula, is the same as cos squared t minus sine squared t. And of course, cos squared t is the same as 1 minus sine squared t, then minus the other sine squared t. So of course that's the same as 1 minus 2 sine squared t. Next, if we look at the formula for x, we can see it's relatively simple to rearrange it to make sine t the subject of the formula. So if we subtract 3 from both sides, we'll have x minus 3 is equal to 2 sine t, and then dividing by 2, x minus 3 over 2 is equal to sine t. Now, since we know that cos 2t is the same as 1 minus sine squared of t, we can substitute that into the equation for y. So y is equal to 4 plus 2 times cos 2t. And cos 2t is 1 minus 2 sine squared t. And we of course know that sine t is x minus 3 over 2. So if we want, we would know that sine squared t would be x minus 3 squared over 2 squared, or over 4. So using that, we will see that y is equal to 4 plus 2 times 1 minus 2 times sine squared t, so 2 times x minus 3 squared over 4. And if we now look at that, we can now simplify the expression, which will be y is equal to 4. 2 times 1 is plus 2. We've got plus 2 times minus 2 is minus 4, but of course it's divided by 4 as well, so the 4's cancel out, which gives us minus x minus 3 squared, which is the same as y is equal to 6 minus x minus 3 squared, which is the equation that we were asked to show that the parametric equation satisfies. Okay, part B1 is to sketch the curve C. Now, so that I don't have to flick between pages, I've got another copy of the question, and I'll start that on a new sheet. So B1, first of all, we have this Cartesian equation for the curve, or at least part of the curve, which is y is equal to 6 minus x minus 3 squared, and of course we still have the parametric equations. Now, one thing that you would notice is if you were to expand this out, it will include a minus x squared term. It will be minus x squared and then various other terms, including x and a constant. Now, any quadratic like this is a parabola shape. If it begins with a positive x squared term, so plus x squared plus 2x squared plus 3x squared, it's a U shape. And if it's a negative x squared term, it will turn into an N shape, this kind of shape of parabola. So we know that the equation will correspond to either a parabola or some part of a parabola. Now the second thing that we could look at is if we think about the x value. We can see that x is equal to 3 plus 2 sine t. And t varies between 0 and 2 pi. So if we think about how sine varies between 0 and 2 pi, we would know that a sine curve looks roughly like this, with the maximum at 1 and the minimum at -1. The maximum occurs at pi over 2, and the minimum occurs at 3 pi over 2, both within the range. So we can see that sine t could vary between -1 and +1. So the minimum value of x would be, so when t is equal to 3 pi over 2, we would have the minimum value of x. So the minimum value of x will be 3 plus 2 times -1, so -2, which will be 1. Likewise, the maximum value of x occurs when t is equal to pi over 2. In this case, x will be equal to 3 plus 2 times 1. So 3 plus 2 is 5. So we can see that we have the end points of the curve, the maximum, minimum point x values for the curve are 1 and 5 for the x value. Of course, we need to know the y value. So what we can do is plug in these t's into the parametric equation for y, or we could use these x values in this formula. And what we'll see is that this coordinate is 1, 2, and this coordinate is 5, 2. So if we were to, those are the two endpoints of the curve. So we can now begin sketching a curve. So we have one point here and one point here, which this is 1, 2, and this is 5, 2. Now we've also established that the curve corresponds to the n-shaped parabola, or at least part of it. Now because these are equal values, they would correspond to two equal sides of the vertex, or the maximum of the parabola. So the part of the parabola that we're seeing must be this part. Now by symmetry, we could see that it has to be halfway between these, or 3 across would be the maximum. So the maximum here would be 3 across, and when would that occur? We would need our y value. So again, we could use our formula to find out what y is. So it would be 6 minus 3 minus 3 squared, or 6 minus 0 squared, so 3, 6 will be the maximum point. And we've now completed the curve. So for part B2 though, explain briefly why C does not include all points of the curve. So of course the full curve would be the complete parabola. But here we know that x has to be between 1 and 5 inclusive. Yeah, because they both occur within the range of 0 to 2 pi. So what we can say is sine t varies between -1 and +1. I should label that as B2. So 1 is less than or equal to x, which is less than or equal to 5. And that's the last part of part B. Finally, we have part C of the question, which I will again do on a new sheet, so we can look at the question and the answer at the same time. Okay, so now we have this question about a line with the equation x plus y equals k, where k is a constant. It intersects the curve at 2 distinct points, and we have to state the range of possible values of k, writing your answer in set notation. Okay, so let's have a think about this. First of all, the line. Let's put it in the more familiar format of y equals mx plus c. So if we rearrange the formula for the line, it will be y is equal to minus x plus k. And you can see the gradient of this line is -1, and the y-intercept is k. Now if I do a rough sketch of the curve that we had before, we'd see it's like this. Remember this point here was 5, 2, and this point here was 1, 2. And the line, since it's got a gradient, a downward gradient, would be going down. So you can see if it goes over here, it would only cross the line, cross the curve once. And if at some point it would start crossing through the curve at 2 points, and it would cross the 2 point here, and eventually when you go up here it would miss completely. Now if you notice that, in order to, the end point, the second point that it crosses the line, it is always further across than the first point, if you want. And the furthest point that it could cross the curve, the line could cross the curve, would be at 5, 2. So using that, we can work out what a possible value of k. It has to go through 5, 2, and the furthest across it is. So we can see that we can plug this in to this formula here. So it will be 5 is equal to minus 2 plus k, which gives us k is equal to 7, which would be the furthest right it is. Now, of course, if we were to lift the line up a bit, it would still keep crossing the line until eventually we missed the curve completely. So k has to be greater than or equal to 7. Now, there's a second point. Of course, we could keep going, but we don't want to miss the curve completely, and we don't want to just tangent the curve at one point. So we need to look at the criteria for that. Now, the way to do this is to think about simultaneous equations. So we already had y is equal to k minus x, but if it's going to cross the curve, it must also equal 6 minus x minus 3 squared. Okay, and what we can do is expand out the brackets here. Forget about what the value of y is. We just know that we want this equation to have two solutions. So because we want two places to cross the line, so k minus x is equal to 6. If we expand out this brackets here, it's going to come out to 9 plus x squared minus 6x, and then we could simplify this, which will give us k minus x is equal to 6 minus 9, or minus 3, minus x squared plus 6x. And what I like to do is always like to have a positive x squared value, so I'd bring it to the left-hand side. So this would now give me x squared. I would subtract 6x from both sides, which would give me minus 7x. This is minus 3, so I'd add 3 to both sides. So I'd have plus 3. I've already got a k as well on this side, and that would be equal to 0. And you can see it's a quadratic equation. The coefficients for x squared is, which we usually call a, is 1. The coefficient for the x term is minus 7, which we usually call b, and the coefficient of the constant is 3 plus k, so c is k plus 3 or 3 plus k. Okay, and since we know that there are two solutions to this equation, we want to have a discriminant which is greater than 0. So b squared minus 4ac must be greater than 0. And if we write that using the information we've got, b squared is 49, and then it's minus 4ac, so it will be 4 times 1 times k plus 3. So 4 times 1 times k plus 3, and that has to be greater than 0. Okay, and if you look at that now, what we will see is it turns into, if you expand the brackets, you've got 37 minus 4k is greater than 0, and if you bring the 4k over the other side and divide by 4, you'll see that 37 over 4 has to be greater than k. So k has to be less than 37 over 4. If you work out that, that's 9 1/4. K has to be greater than or equal to 7 and less than 9 1/4. So in set notation, we write this as follows. K is equal, curly brace, K colon 7 is less than or equal to K, which is less than 37 over 4, close the curly brace. And the question is now complete.